Is everybody having a good time? Excellent. Well, I'm about to ruin that. Because, well, first of all, I know everybody now is a snowflake, so I'm going to have to be really, really careful. In the old days, as a speaker, it was fun because you could play with your audiences and upset them, and it was perfectly legal. But nowadays, you have to warn ahead of time what you're going to do. So this is what's going to happen in this talk. In this talk, I am going to make you depressed. I am going to tell you that the stuff you're doing is wrong. I am going to make you so sad that there'll be people crying, right? You may have to hold hands. If you see your neighbor reaching for something sharp, please firmly stop them, because it is going to be really, really bad. But don't worry, because then I will make you all happy again. And by the end of this, look at this. We started with a unicorn and we end with a unicorn. And that's just the way it was supposed to be. So that's what we're going to do. I'm going to tell you that the way you're writing Elixir code right now is wrong. And the way the core team is writing Elixir code is wrong. Everybody is writing Elixir wrong. And then I'm going to show you how I think you should write it correctly. Now, just to start with the depression, I'm going to use the world's most overused quotation. Right? Those that cannot remember the past are doomed to repeat it. I have been guilty of using this many times on slides because it's an important one. I hate the fact that people don't know their own history. They don't know the past. They don't know what other people have done in the past in computing, and therefore we keep reinventing mistakes. So that's a really big deal. Honor your history. However, sometimes history is just a drag. History holds you back. History is kind of like a dead weight that you're carrying around with everything that you do. So in the real world, there's a balance to be made. And the balance is between honoring the past, doing what we should do because people have seen it works in the past, and creating a brand new future. And sometimes to do that, you have to ignore the common wisdom and just go for it. Right now, I think in the Elixir community, we're doing way too much of the honoring the past. And we need to fix that. Partly, this is due to Elixir's heritage. And we're going to look at three areas: Erlang, Ruby, and Rails, somewhat contentious. But let's look at the overall problem. I think that there is one major problem that we're facing in just about every Elixir application out there. The 18-wheel truck that's holding us back. And that's coupling. Pure and simple. It's this design issue called coupling. And the reason that this is significant is that coupling is the thing that prevents us from making changes to our code. The more things are coupled, the harder they are to change. I mean, you can think about a physical process. Imagine, if you have a bridge structure. You have all of these triangles. Why? Because the triangles couple all the points together and make it rigid. You can't flex it. Well, it's the same as true in code. The more things are interdependent, the harder it is to change one of them, because those dependencies ripple through the entire application. Resisting change is the enemy. It's what we fight against every single day, because we write programs in a changing world. And if the world is changing around us and our code cannot change, then our code is immediately out of date. And not just when after we've written it, as we're writing it, requirements are going to change. So the only way to be agile is to have code that's amenable to change. In fact, I only have one principle of design. Well-designed code is easier to change than badly designed code. That's all there is to it. Whenever you make a decision, say, is this doing it this way going to be easier to change or harder to change? And if you just keep asking yourself that question, then you'll be doing good design. You don't need all these fancy, patterns and all that kind of stuff. Just think about this every time you do something. So, our mission is to create well-structured and highly decoupled solutions. Because if we do that, I very much hope it's going to lead to code that is easier to change, deploy, maintain, and reuse. And after all, that's what we all want. So, let's start on the real serious downward slope. Erlang. Erlang first came about, as you all know, in the mid-'80s as a response to a requirement. Somebody had to write software that drives, this not particular one, this is Plessy, and they were talking about Ericsson, but I mean the same concept, telephone switches, exchanges. And they had some incredible constraints. They had to write software that was incredibly reliable, highly available software. Software that was, by its very nature, incredibly asynchronous, that was doing thousands of things in parallel at the same time. Each of those little blades in there, I don't know how many processors are in there, but each one of them is doing its own thing, switching calls or whatever else, right? It's a really tough environment, and that is the environment that Erlang was invented for. Now let's think about that environment a little bit. When you're writing code in that environment, you're writing code in an incredibly well understood, highly engineered environment. You can bet that every piece of hardware has gone through n number of design reviews. It is specced up the butt. You know exactly how everything is going to work. Your functionality, although it's big, is actually largely replicated. Yes, you're dealing with 10,000 calls, 100,000 calls, but each call is roughly like the other calls. All the change that you do is managed change, which is great. And the entire environment is incredibly high ceremony. So that is the task that Erlang has been optimized for. And it does an unbelievable job. Everybody goes around talking about 9 nines reliability, which of course is totally and absolutely meaningless as a number, but it's taken to mean it's quite reliable compared to most software. Unfortunately, times have changed. Actually, probably a good thing that times have changed since the mid-'80s. He's making popcorn in his pants. However, that has not stopped us from copying stuff from Erlang. So, Erlang, good then. Some parts of it, no, that's not true. A lot of it's still good now. But we just cargo cult everything because we're told we have to, right? Everything is great in the Erlang world. We have to copy everything. So let's think what we copy. Number one, we copy the idea of application. So let me ask you a question. What is an application? And this is going to sound like I'm nitpicking. I'm not. It'll get into it a bit later on as to why. But what is an application? Is it the thing we create with Mix New? Well, it thinks it is, because every Mix New project has a mix.exs, and in there is a little def application. So obviously, there must be an application in there. Or maybe, is it the thing that we build a release for, which needn't be the same? Or is it the thing we run? Again, which needn't be the same thing. And the simple answer is, sure, yeah. It means nothing. We talk about applications without really knowing what we mean. And that is a really big issue, because when we name things badly, we make bad decisions. We use those names to guide our decision-making, and the names are wrong. One of the big problems I've got is you cannot tell from looking at the source code what's going on. It is not possible to look at Elixir source code and say, yeah, this is what I run. The best you can do is some kind of weird dependency analysis and try and find the thing that has the least things depending on it. And that's crazy. Something else we borrow from Erlang, configuration. So let's imagine we have a some kind of thing here that makes payments, right? So it's got access to our bank account. And it obviously has a super secret password, and we stick that into the config, and that config is part of that application, and it's all bundled up all very nicely. All right? Now, we come to use this. So we have two applications that use this, and they both declare our payment thing as a dependency. So now, where's the configuration? I will take answers from the audience. All right, the configuration is down here. Not there. And so now what we're having to do is duplicate our super secret password down into two apps that don't need it. They don't care about it, but they need to provide it up to this parasitic thing here that they're using. Now, can we fix that? Yeah, we can fix it. We can make payments into a service. By a service, I mean here a totally independently running entity. Right? It'll run on its own node. It'll be started separately from all the rest of our code. And if we do that, then it uses its own configuration. And life is wonderful. So, maybe. Because sometimes we may need to configure this with things like limits or whatever else that come from the applications. And we either have an all or nothing. We either have this as the configuration or that's the configuration. But even if we do want to go the service route, how do we do that? The default in Elixir, the way we are encouraged in Erlang and Elixir to write stuff is to write one big application and bundle everything together. And it actually can be quite hard to come up with service-type architectures that easily deploy and update because the tooling doesn't assume that that's what we're doing. Right, other bad things that we inherit from Erlang. Gen server. Yep, I said it. Here is, okay, first of all, in Erlang, the standard, I edited Joe Armstrong's original Erlang book. And at one point, he had this line of, how do you create a gen server? Well, you're using Emacs, obviously, and you include the template this way. So I went and I included the template. 127 lines of code is a gen server that does nothing. Right? Now, in Elixir, we don't have that problem necessarily. We still have to write a fair amount of code, but not a whole bunch of code. This actually may not be true anymore. I think we may have to have an init call in here now. But anyway, so here's a standard gen server. And this is drawn from the Elixir documentation. Let me ask you to identify the various components in here. Let's start off by saying, what's the API? Well, we're told that the API is the stuff above all the handles, right? So really, I would say this counts as API because we're going to call stack.push, stack.pop. That's our API. So if I was a consumer of this module, that's probably what I'd want to be able to find very quickly. Second question, where is the implementation of the server? Well, kind of there. Oh, not quite aligned. We have server jiggle. So this is kind of spread over there as well. Now let me ask, where is the actual implementation of our stack? And it's kind of there. Because here's where we set the default up. Here's where we split it into a head and tail. That's where we return the head, and then here's where we update the state with the new item when we push. Now, go find a really good book on software design. If that's Joe, tell him I'm not taking calls. Find a book on software design, and you tell me what that book will call this particular style of software development. I looked for a long time until I came across the answer. It's called Dog's Dinner. Everything is just messed up in one place. Actually, it looks like a dog's dinner after it has been eaten and then thrown back up again. It is absolutely disgusting. And yet, if you look at the Elixir source code, you will find 1,000-line gen servers in there, where all of the implementation is messed up down in a whole bunch of handle XXX calls down the bottom. Almost impossible to read. But we do it because it's gen server. And that's inviolate. It's the root of OTP. Well, it sucks. Unfortunate Ruby things we copy. See, I'm an equal opportunity disser. Project structure. If you do bundle gem, you create something that looks like this. If you do mix new, you get something that looks like this. Is there a similarity? Yes. First question for you. Why the hell is it called lib? I'm waiting. I have no idea. It makes no sense at all to me. Lib, or lib as some people call it, right? No sense whatsoever. And then here's the biggest question I've got. What the hell is that file for? In about half the projects I've seen, it's empty, or it still contains the hello world string. In the other half, it contains the entire application. It's just total, doesn't belong there anywhere. And here, a little application buried down there. But it's not really the application file, it's actually the supervisor, but don't tell anybody. So you say, okay, but that's okay, we've got umbrella projects. And umbrella projects that are split our project up into lots of small components, and that's the way we should be doing it. So we end up with a beautiful structure like this. We have a top-level app, and then we have the shared dependencies up there, and then we have all of the various sub-apps underneath it. So, does this solve our problems? Does this solve the application confusion? Is it a library? Is it an application? Absolutely not. In fact, it actually adds to it, because now we have this dummy application which doesn't actually do anything and isn't actually run, but actually contains all the interesting stuff. Does it isolate the configuration? Absolutely not. Does it allow us to reuse our sub-applications? Not easily. It actually makes it harder than if they had been separate applications. So, is this simpler? Must be simpler. Sorry. It really doesn't help at all. I've never used umbrella apps. That's not quite true. I very rarely use umbrella apps. If I have to do something similar, I use file dependencies. Because if I use file dependencies, at least that way I know I've got isolated components that I can merge together. Now, the big one. Unfortunate things we copied from Rails. Fortunately, the answer is very simple. So, this slide took me about an hour and a half to get right. But here is Rails new and Phoenix new. Rails, 44 directories, 59 files. Phoenix, 28 directories, less directories, 42 files, getting on there. From this, we can conclude that Rails is 70%, we are 70% as good as Rails. It's ridiculous. Here's our Phoenix project structure. And recently, 1.3, we split everything out, right? So now we have all of our, quote, contexts, our business logic, out in a separate place. That must be better, right? Sure, because what we've done is we've actually increased the coupling in our application by forcing it into that particular place. We have our HTTP interface here. We have basically our web server down there, and that's going to be calling back and forth with here. They're going to be pretty intimate. And if you've ever tried to use Ecto both inside and outside of Phoenix application, you will know that it can't be done. It is coupled. So once you've got Ecto inside Phoenix, you cannot send a message to an Ecto running outside of Phoenix. So you've got coupling everywhere, and you still have that damn file there. It is the entire whole enchilada, just waiting for a dog to come along and eat it. So that is the despair part. That is why everything is wrong, why it's all bad, why you all suck. So the question then is, okay, what can we do about it? And this is where I get to be positive. I'm English, so that's kind of hard to do, but I'm going to try. First of all, here is today's number one rule. You will take this away, you will tell everybody you know about it, and they will tell everybody else they know until the entire world knows. We no longer use the word application. Application is banned in the Elixir community. Instead, we're going to use one of three words for the things that you create using Mix New. The first word is library. A library is for those components that have no state. They're isolated as their own applications because I wanted them to be reusable, but they have no state. The second word that we're going to use is component. And a component is a thing you create with Mix New that does have state. It's going to be one or more processes. A library is not going to be a process. A component is going to be one or more processes. Those processes will run either on the same node as other code or potentially on their own node. So they are inherently going to be accessible across a network. And then last and least in terms of effort is assembly, which I think I borrowed from Microsoft. Assembly is the deliverable. It's what you actually ship. It's what gives value to your customers and clients. An assembly doesn't have any code in it. An assembly is just a configuration of components. So it might look something like this. Here we have the little yellow circles are libraries. The ones in the middle there are components. And the whole thing together is an assembly. Now this is just naming. It's just nomenclature. But it means that we can start thinking about individual parts of our assembly as their own freestanding components. We no longer throw everything into lib. Instead, we throw it into its own project and just combine them when we need to at runtime. It is not hard to do, and I'll show you how a bit later on. One of the cool things about this is that reuse is easy. And we can actually do reuse as in the same instance gets reused or just reuse in terms of code reuse. And it just falls out automatically because each of these things is isolated, freestanding, and then composed effectively at runtime into our assemblies. Configuration. We're going to stop using this ridiculous configuration scheme that we're given, and we're going to start doing it properly. And properly means active. Configuration is now going to be a component, a process. It's stateful. Every assembly has a configuration component. That component receives values. It receives values from the overall configuration of the assembly, and it receives values for each of the components in those assemblies. Actually, not in that order. It does the components first, and then it does the assembly. If a value is set in an assembly and then overridden if it's set in a component and then overridden at the assembly level, then it becomes the assembly's value that sticks. So when we're starting, or if there's a configuration change, the flow looks like this. Our individual components here each have a default configuration, which effectively is their defaults, which get fed up to the configuration module. Configuration module then reads the assembly configuration and stores that result. And it does that on startup, and it does it whenever there's a configuration change. Now, whenever a component needs configuration, it's going to use this nice configuration API up here to get it. And therefore, our configuration is now assembly-wide, and automatically it handles all of the cases that we want where it overrides or doesn't override. This just seems to make sense. It also means I can have a nice API into configuration where I can actually have maybe some kind of web interface that allows me to change it on the fly for a running application. And because onConfig change will get invoked, we'll just automatically update stuff. Last, you may say, but what about Phoenix applications? What was the rule I gave you a few minutes ago? No applications, thank you. They're not Phoenix applications. We're no longer writing Phoenix applications. Now, we're going to write Phoenix components. What does that mean? Here's my assembly for maybe playing poker. So I have some libraries. I have some components, the quote, business logic. And oh yes, I have one more component. That component down here is the front end. And guess what? That's a Phoenix component. How much business logic is there in that component? 0. It is purely a view layer. It's handling the channels and the HTML. And all of the work is being done behind. Why? Because it's the damn user interface. You don't put business logic in your user interface. You don't bundle your contexts into your web server. It's a web server. Right? You guys have got more pride than that. This is how it's going to be from now on. GenServer. I complained about GenServer. And I showed you this example. And I complained because it strikes me that there is a whole bunch of totally useless crap in here. Stuff that you don't care about, I don't care about, God probably doesn't care about, but the Erlang runtime apparently does. We don't need to specify this. Right? This is a okay, I've got to be careful here. I was about to say this is a sacred cow that we have to slaughter, but apparently that's offensive. So I'm instead going to say this is an idea whose time has passed. Right? We need to say, yes, the implementation of GenServer is great. At least we're told it's great, and I have no evidence that it's not. But the expression of GenServer, in particular this expression of GenServer, sucks. Because it totally and absolutely obscures what we are trying to do. So I've been playing around with options. And I've got a module now called component that lets me do this. So it's the same implementation, def module stack, and I have two functions. This is a one-way function, this is a two-way function. The one-way function allows me to push a new value onto the stack, and a two-way function allows me to both set the state and also return a value. This is the most complex case. You can actually do it a lot simpler if you're just setting a state or just returning a value. So that is a server. Right now, I'm showing you a named server. So that's a conventional singleton named server. You can also say component.pooled, component.hungry, and component.library. And in those cases, you'll get a dynamically allocated servers. You'll get something I call hungry consumer, which is a bit like a GenSage, where your consumers are sitting there saying, give me work to some overall scheduler. And you get the no-state version, the library version. And you go, but you just thrown away GenServer. No, I haven't. Because behind the scenes, that code is generating this code. And in this code, here we have our API, push and pop. Here we have our implementation of push and pop, put into their own module, which means that I can unit test them in isolation. Here we have our server code, which is just standard gen server code. And then here we have our component interface code. And the reason for that I will show you in a minute. Apart from the cool fact that I needed to have a function that returned the configuration of this component for various nefarious reasons, and I didn't want the name to clash. And now that we can have UTF-8 names in Elixir, then component info written backwards and partly upside down is a perfectly valid function name. You've been warned. So nothing there has been lost. It is still gen server. But you don't have to write all of the fluff. You just write what you want. Component structure. They look like this right now. Well, first thing we can do is get rid of that stupid formatter.exs, because no one ever uses it. Then we're going to get rid of config, because you don't need that. Then we're going to get rid of that stupid lib directory. Because, damn it, I am writing a stack. The most important file in this entire thing is that. It's the implementation of my stack. Why do I need to bury it? Of all things, right? Formatter.exs is at the top level. My stack, my main program, is buried in something called lib? Ridiculous. So, there's a simple one. We don't actually need the mix.exs either if we use sensible defaults, which I would like to do, but I just cannot see that flying. If our stack implementation gets more complex than we'd like to put into a single file, then we can create that, and I don't know whether to call it lib or stack, and I'm on two minds about that, and we can put stack.popper and stack.pusher in there. Why do I have that structure, and why don't I, by default, create that subdirectory? It's because I don't want you to use it. I want every single component that you write to fit into one file. I don't want all of this extra stuff. If you write a 1,000-line file at that level there, I'm going to take you out and beat you up with a rubber hose. Right? That's not the point. The point is to write lots and lots and lots and lots of trivial components and then compose them all together. Because that way, you get reusability, you get maintainability. You no longer have to release the entire thing. It's just so much nicer. Talking about deployment. There is no easy way to deploy a component-based Elixir application. What I want to be able to do is to deploy my assemblies. I want to be able to say, here an assembly consists of these components, this configuration, et cetera, and oh, I want to deploy it to a dynamic set of servers. I want these components to be able to discover each other at runtime. So once they've been loaded and started, they need to be able to communicate back and forth. And they need to have things that are obvious, that we don't have right now. Common logging, common stats, common monitoring. All of those kind of cool things that every other platform has. So let me introduce you. Someone tell me who that is? It's Noddy. Noddy is the Node Dynamic Management System. Yeah. Okay, Noddy actually exists in a very simple form. Noddy is the component assembler. It takes an assembly configuration. First thing it does is it looks through it for a list of nodes. And associated with each node will be a list of servers. Sorry, other way around. A list of nodes and a list of servers. Associated with each server will be a list of nodes to run on that server. So Noddy is going to go through and is going to create as many nodes as is needed on as many servers as you tell it to. Once the nodes are there, well, not quite once, but it's going to be doing this in parallel, it then starts kicking off components. So it's going to go to components on node A, and then it's going to do the same on B, and the same on C, et cetera, and again, in parallel. And Noddy's going to do a little bit of orchestrating to make sure that things start at roughly the same time. It's going to handle things like handoff to configuration. It's going to handle common logging and all that kind of stuff. So our Noddy configuration is an assembly configuration. It contains node definitions, and all that is a list of node names. There won't just be N1, N2, but it's going to contain a set of server assignments. This is going to tell us how we assign those nodes to particular servers. So in development, I probably want to run all of my nodes on localhost, and the same in test, maybe. But in deployment, well, I'm going to do something different. So N1's going to run on .42, and did you realize, by the way, that's perfectly valid Elixir syntax? Is that cool? Because you can actually have colon star as a symbol, so therefore you can use star colon as a map key. There you go, that was worth the price of admission, wasn't it? Anyway, so that's going to start N1 on this node and all the rest on the other node. And then finally, we're going to tell it what components to use, where to run them, and then various other configuration stuff. So here, I'm going to run component 1 on both N1 and N2, and oh, by the way, I'm implementing it using the module called dictionary. And then here, I'm going to run component 2 just on N2. So that's going to create 2 copies of it's going to create comp1 on 2 nodes and comp2 on just 1. So Noddy launches nodes and components, provides global name service, et cetera, et cetera. I have written both the component library and I've made a start on Noddy. The existing one does that. It did use Swarm to do pub/sub, but I got some problems, so I kind of backed away from that. And I do have a version that's using statsd and stuff to do monitoring, but it's not reliable, so it's kind of like not there yet. And I've got myself a little stack of 5 Raspberry Pis in a tower, which I'm using to do testing, so I can actually deploy into 5 servers at the same time. And it works. Is it perfect? Absolutely not. It's crap. It really is. It needs a whole bunch of work. It's nothing more than a proof of concept. It's nothing more than an experiment to say, okay, it's all very well saying we should do it this way, right? But in practice, it's impossible, right? No, let's see if it's possible. Let's not go around saying, oh, you can't do that because of this. Let's instead say, what happens if you take what looks like a good idea and actually try to run with it? So both of these are up on GitHub, and I would love anybody who wants to take a shot at it to work it through. I got a little roadmap in my head, which I can make explicit if people want, but I'm not in charge of this, right? It's just throwing it out there. I think this is a direction in which we should go. I think we should make Elixir easier to use. I think we should make it something that anyone can write a component in 3 minutes, slap it out there, and then have other people use it. This is the future. This is the way software is going to be developed. And we have the opportunity to be there. So, yes, we need to learn from the past. We need to revere the past. But we are not bound by it. We need to reinvent. And we need to do things in a way that makes sense for us in our current time. And then last, but by no means least, in fact, the very most important thing at all is you've got to remember to have fun while you're doing it. So, thank you.